Let's get started. Today's lecture, okay? 11th week, 3D computer graphics. Today's topic is as a continuous lecture from the last week. Last week we handled some geometric modeling. So we're gonna take a look at geometric modeling as well as rendering, okay? Visualization using 3D application, SketchUp, mostly using SketchUp, but we need to review the literature we had walked through so far in this semester, okay? Because as one of the prep for the exam next week, okay? So today's lecture going to be really essential, okay? Regarding 2D, especially focusing on 3D computer graphics. So several issues going to be handled in today's brief essential lecture, 1 hour lecture today, okay? We are on 11th week for SketchUp 3D. Next week we have an exam, okay? In course website, our class website, there is course data folder, and there I uploaded sample question for the midterm exam. So you can find out one single slide, one page example on the course web. I'm going to show you that page in today's lab exercise. Okay, what to do today here? Very simple, 3 lab exercises. First lab exercise, rendering. Second one, modeling. Third one is visualize your model. In other words, visualize your model have learned for the lab exercise number 2 using some more architectural building modeling as well as some application of your rendering skill learned in lab exercise number 1. So we're going to walk through lab exercise 1 and 2 as well as some part of 3, and then you will be in charge of handling lab exercise number 3. And another very important thing for today is picking up your final project, okay? Pick one of the subject listed in this slide is your final project subject. It's kind of first come, first resolve, okay? So total 10 works, and this page will show you what to do for the final project. Simply say, CAD plan drawing, 3D modeling in SketchUp, retouching, visualizing by Photoshop, design final presentation image, render scenes and diagram sketch or some other pictures, edited by Photoshop or other graphic software, anything else. Representatively PowerPoint, okay, or even Prezi, whatever. Another one, your own Google website, posting entire your material for the presentation. At the end, 5-minute oral presentation, okay, based upon your slide. Make your digital design presentation using PowerPoint or Prezi. For what? For one of them, okay? Number 1, Walmart. Number 2, Alpha Bank. 3, Meat Market, Soul Movie. Number 4, number 5, 6, 7, 8, 9, 10. Billard Bear and some Foodsmith oven grill. You don't need to build entire structure. Some building, take a look. This one is small size building, and this also small size or just mid size or just one tiny part of bigger building. But take a look, comparatively big size floor plan, and this one also large size. Take a look, comparatively big size, okay? This is kind of the biggest one, the biggest floor plan. You don't need to build the entire. You can pick some part, okay? Some part, this area, corridor area, meeting room area, lobby area, and so on, okay? Based upon those existing design representation. You have to focus on some specific part, okay? In order to visualize your own design material for final presentation. Also, you can focus on two spots, okay, two areas. First one, lobby area. Second one is office area. Visualize two different places. Not entire 100% model. That's okay. But anyway, you have to spend lots of time for modeling, rendering, visualizing, representing your selection. So until today, you have to choose your final subject. Per each, 3 maximum, okay? So if you come 3 occupied this one, no more students can get this one, okay? That's the rule. Anyway, total 10 options given, and I'm gonna review with you one by one whether your project going to be selected or not. Okay, let's get started. The reason I put the term review here means this is actually review and a preparation for the exam next week, okay? Let's walk through quickly in this essential 1 hour lecture today, okay? 1 hour lecture, and then we're gonna finish lecture before getting into the lab exercise, okay? Without break. Let's get started. 2D drawings by AutoCAD. Let's review 2D drawing by AutoCAD. I'm not going to talk about 2D vector images. I'm not going to talk about 2D vector images or bitmap images. Now I'm going to talk about drawings, okay, 2D drawings. What is drawing? What is, or even say, what if we are saying drafting, okay? 2D drafting and drawing. And I like to make a comparison between drawing or drafting and modeling, okay, modeling. So what is modeling? What is drawing? 2D drawings by AutoCAD. Let's take a look AutoCAD quickly first. You have reviewed this one in lab exercise hours. You have tried to draw something even if we didn't spend not much time. But next semester, we're gonna asked to draw lots of AutoCAD-based floor plans because they are industry standard. Anyway, this is AutoCAD interface. As you know, it has GUI interface, which has menu, icons, toolbars, tapped grouped icons, ribbon interface, something like this. For typing, clicking, dragging, and dropping, your keystroking, simply graphical user interface is working based upon those user interaction. So we have learned the CLI, GUI, NUI. So you have learned GUI, NUI. These are our up-to-date interface, mostly NUI when you use your smartphone, smart device. But our applications mostly on GUI. Your computer interface right now is GUI. But how about AutoCAD? This one has partially command line interface. You have to type command or put numbers. Think about SketchUp. You have to put numbers for dimension, precision dimension, okay? Precision numbers you have to put. So partially CLI and mostly GUI. Take a look, user interface. Coordinate system, XY or XYZ, mouse cursor, menu bar, ribbon interface. How about this one? Command line. There is a command line, okay? You have to type line when you want to draw line. You have to type rectangle or REC when you want to draw rectangle. And you have to click and type, comma, type, spacebar or enter, and so on. That's the interface of this one, AutoCAD. How to CAD in AutoCAD. What is the meaning of how to CAD? CAD here means computer-aided design. I told you before, computer-aided design, we don't need to say computer anymore. So just the design. In other words, how to CAD means how to design, okay? How to design in AutoCAD. First, do something from nothing. Simply say, create object. Line, polyline, circle, arc, rectangle, they are all commands, okay? One of commands for drawing each object. Secondly, do something on the existing object. In other words, modifying, editing object, move, rotate, mirror, array, fillet, trim, selection, group, layer, erase, all they are doing something on top of existing object. And utilities, author, snap, undo, and so on, and more, okay? So let's take a look how to draw a line, how to draw polyline. Basic CAD interface has 3 ways: clicking menu, clicking icon, or typing command. Take a look. You know what is clicking menu. You can click draw menu and select line and click, click, click. That's it. Or simply mouse over on line, and then this pop-up help will show you very intuitively how to draw line. Simply click point 1, point 2, point 3, and then connections, okay? So this is line icon, so-called GUI based line drawing. How about command line based? What you need? Type L, okay? L is frequently used command for line, or you can type line, okay? That's the CLI base, command line base. Click the stop point, end point, terminate line, and then your line object created. So 3 parts: begin command, type L, perform command, which means start line and intermediate points, end points. At the end, terminate command, okay? ESC, spacebar, in order to finish your command. So keep in mind, you already used this process, but anyway, this process is always similar to other kind of applications. Next thing we need to remember, recall from your use scenario from AutoCAD is layer, the concept of layer. Take a look. This one shows you hierarchy of layers. First layer has title, second one index, next one text, image, photo, editor information, utility, navigation. At the end, final page has entire component. So this concept of layer, or this functionality, layer function, has equipped in Photoshop, this kind of AutoCAD. How about SketchUp? SketchUp also has a layer, okay? So you can control layers in order to turn on and off easily. How about 3D Max? Also it has layer. Layer is very frequently used concept and very important and useful thing, so you have to remember. Especially in AutoCAD, take a look. This is AutoCAD layer. CN usually means center line, okay? Center line for words. How about words, okay? Text, furniture, dimension, corridor, columns, all they can be assigned by this kind of layers with appropriate names. You can turn on and off, or you can change colors. How about center line? It's in red color, okay? That means if you find red color, that is the center line for your words, okay? So basic commands are listed here, so you need to take a look this one when you use AutoCAD. Okay, let's take a look at floor plan drawing. Floor plan drawing means drafting, okay? Precision drawing by AutoCAD. Take a look. This is simple representation of 2D AutoCAD for this building, for this floor plan, okay? But actually this is not enough, okay? Some layers turned off. This one only displays architectural symbols, which means doors, windows, or walls, okay? Take a look. Center lines of the walls and dimension lines, text, okay? Furniture layout, okay? So even more lines we need, but actually take a look this one. This one has document frame and very elaborated dimensions. You know the symbol, okay? The symbols. and some text metadata for this floor plan with its title. Okay, this is sort of one single page full version of the CAD plan. Precision drawing by AutoCAD. You have to know not only how to draw using AutoCAD, but also what are represented in given AutoCAD plans. You have to know industry standard symbols in CAD plans as well as human scale, architectural scale. Again, you have to know industry standard. That's first reason why you have to learn, why you have to use CAD plans. Second reason is you have to understand scale, dimension, human scale, architectural scale. Take a look. You know this is double folding door, okay? But actually, this is symbol, not real section profile, okay? If you see this one on top of 3D plan, you cannot see this kind of symbol, okay? This is just a symbol, not real visualization. Anyway, this is kind of critical reason why you have to know precision drawing by AutoCAD. Knowing industry standard symbols as well as human architectural scale, okay? Take a look, this very, very simplified floor plan. Even this one has lots of information, walls, thickness, and dimensions, text. But anyway, this is 2D drawing, okay? Just original drawing is just 2D. How about this one? Looking something complicated, but anyway, this is another 2D, not 3D, okay? But how about this one? This is very commonly found nowadays, 2D representation for apartment floor plan based upon this kind of 3D model. If you have 3D model, do you need to draw again for 2D? Sometimes you need, but mostly you can extract. 2D drawing extracted from 3D. That's the drawing, okay? Extracted from 3D. Next one, also same example. 2D drawing extracted from 3D. So typical CAD-based plan representation is here, but the difference between this one and this one is this is original 2D drawing, drawn by AutoCAD, PowerPoint, Illustrator. No one cares, okay? If this one has industry standard and symbols, but this one generated by 3D applications, extracted from 3D, okay? That's the difference. How about this one? Of course, this one extracted from 3D. Let's take a look, CAD versus modeling. Sorry, CAD as a drawing tool versus CAD as a modeling tool, okay? I told you, drawing and drafting, they are equivalent, okay? But how about modeling? Let's take a look, CAD as a drawing tool versus CAD as a modeling tool. We reviewed this approach is conventional, 2D-based representation. And 3D surface model, if you have 3D surface model, just simply place your camera and then you can get 2D drawings. Or you can generate also from 3D solid model. It doesn't matter, that's fine. Anyway, this is 2D drafting approach and this is 3D modeling approach. Extract your visualizations. Front view, elevation view, top view, all they are just visualizations, okay? You don't need to draw again. So this is conventional approach. Front view, top view, so-called floor plan, left view, right view, even bottom view, they give you clues to figure out the shape of this one. But in terms of CAD history, that is the conventional, the earliest approach to represent shape, okay? This is the initial stage CAD application, computer-aided design. When computer invented, they just made 2D drawing-based application. Next phase is advanced one from this one is surface-based 3D. Okay, so now we are dealing with those parts. SketchUp, Rhino, AutoCAD, 3D Max all are in this part. Okay, surface-based 3D or 2D. 3D solid, parametric modeling, BIM. This is not the subject for this semester. It's going to be next year's or your third year's BIM class subject. Anyway, general 3D modelers in varied modeling types. Take a look. Why you need to create your own computational model, not drawing, okay? You have idea, but it's only seen to you. No one can see, no one can capture what is your design. So you try to build your own computational model from your head, okay? For what? For digital design presentation. Why this one presented? Simply because this one supposed to be realized in real world for someone else, okay? If you are a designer. That is why we need to extract plan, 3D sketch, picture, animation, anything from the model, okay? So this is the reason why we need to build a computational model to present your ideas, to visualize your ideas. So what is the important thing? Your universe of this course, okay? This does not need to be same to the real world, but anyway, you need to design your world, okay? Your environment, your computational model using what? AutoCAD, Photoshop, PowerPoint, that's fine. But this semester, you asked to mostly use SketchUp, okay? SketchUp and applications. That's why we need to build a computational model. And let's quickly review design mode. Mode of thought is simply say mode of concept, okay? Mode of concept and concept development. Mode of expression requires some type of visualization, some type of exploiting a medium's unique quality to maximize meaning, to visual equivalence. Equivalent between your idea in your thought and your output, your visualization, okay? Mode of production, of course, in charge of create something. What is the media now we are using? Of course, computers, computer software, hardware, environments, and so on. Simply say SketchUp. How about SketchUp? That is your design tool right now. Take a look in architecture design domain. What is communication? How to communicate? You have your idea, and before computational model, what we have done, abstract, okay? You need to build on abstraction. Abstract means build your design into a specific object, specific drawing, specific thing, okay? What is that thing? Sometimes this kind of roughly hand-drawn diagrams, or sometimes this kind of 3D sketch, 3D drawing, painting. Sometimes take a look, this kind of drafting, okay? Carefully, thoroughly drawn drafting, okay? Take a look, 1893, one of the workers in architect firm, he drew using this kind of tool for architectural representation, okay? One type of abstraction. How about this one? Floor plan, elevation, section, axonometric, isometric. Very architectural and professional looking symbols, okay? symbol-based representation, not real representation, just symbols. Anyway, this is the process of abstract. Nowadays, your computational model in charge of entire this part, okay? Your abstract part. Let's take a look, a sort of history, okay? History of architectural design and construction in our domain. Okay, excerpt from Wikipedia. Take a look at this picture. You know what is this picture? This is Vitruvian Man. Who drew this one? Famous Leonardo da Vinci. Okay, he drew this this painting. For what? To representing human scale. Okay, human scale. Why its name is Vitruvian Man? Vitruvian Man means Vitruvius. Marcus Vitruvius Pollio, born in before Christ, BC 80, 70, not sure. But anyway, around 2,100 years ago, okay? Around 2,100 years ago, Vitruvius is believed as the first architect who invented plans, elevation, and so on. So-called architectural standard, okay, industry standard, conventional standard, okay, in his 10 books on architecture. That is why he is believed as the first architect in human history, around 2,000 years ago. Thanks to him, around 500 years ago, Leon Battista Alberti, I just simply put just one representative architects, not entire person, okay? Not entire man, just some selective person. Alberti also exert something from Vitruvius' approach, but he tried to distinguish architectural design from construction, okay? So-called, take a look. The essence of design lay in the thought process associated with conveying lines on paper. His goal was to differentiate the intellectual task of design from the craft of construction. Okay? He tried to separate architectural drawing as well as craftsmanship for construction, real construction on site. Anyway, he also learned from Vitruvius' approach. Okay, take a look. Louis Sullivan case, around 100 years ago, when modernism architecture kind of spread to public. The phrase "form follows function" is the representative phrase in modern architecture. Okay, form follows function means if there is something without any function, it's useless, okay? Such as decoration. Luxury decoration is nothing. It's useless. That's the basic approach in modernism. That is why modernism buildings always box shape, cubic shape, okay? No decorations. Anyway, also coined by Louis Sullivan, this one, and take a look. Referring to Vitruvius, this modern architecture approach has coined and sort of initiated. Nowadays, 2D computer-aided design system, architectural design system, drafting and design system, 3D BIM system. Even if we are handling this area, computer-aided design, my point here is drawing, invented by Vitruvius 2,000 years ago, and some separation, drawing, and some construction craftsmanship. But take a look, nowadays, even modern architecture, something different, architectural design and construction, separated. But nowadays, actually, by using computers, entire separate processes, they're going to be integrated into what? Into computational models. Okay. Okay, until this history, more than 2,000 years, no computers available. But nowadays we use computers, computational models. Okay, what's the difference? Now we are using some integrated approach. So formally, architectural design versus construction can be replaced with this one, drawing or drafting versus modeling. Okay, modeling your model. The term model here means computational model. So let's take a look quickly about 3D geometric modeling issue. Okay, 3D geometric modeling issues, geometric modeling in 3 dimensions. Last week we reviewed this part. For making this one single box shape, what kinds of subcomponents are there? Vertices, edges, faces, polygons, surfaces. You need to control this edge or face in order to modify or create this object. That's the fundamental approach of creating 3D. Fundamental way number 0 is making primitive. SketchUp doesn't have those primitives, but 3D Max or other tools have those primitives. SketchUp also has some circle shape, rectangle shape, and line drawing tool. They are so-called primitive, okay? Making primitive and modify them again and again until the geometry you want created, okay? The first way is extrusion, drawing section profile and extrude, push-pull. Next one is revolving, wraithing, revolving a section profile. That's the second way. Third way is sweeping, section profile, pathway, and 3D. Follow me tool, similar to the push-pull tool. We reviewed this one last week. What others? This is skinning. In other words, morphing, okay? Star shape, circle shape, rectangle shape. It's a morphing, okay? Morph. Another one is, okay, sorry, take a look, something more. 2D text is representative 2D vector drawing. Very easy to extrude it, okay? And then you can get this kind of 3D. And take a look, section profile and sweeping and revolving, drawing section and revolving to create 3D. Next thing you need to take care of is this one, Boolean operation. What is Boolean operation? How to make this vase cup-like object? A box minus smaller box. That's the easiest way, okay? A minus B, union, intersection, cut. That's the Boolean operation. Take a look. Boolean operation in 2D geometry. If there is A and B, we can define A minus B, B minus A union B, A intersection B, A XOR B, okay? Operations can be defined like this way. How about in 3D shapes, 3D geometry? If you have A and B, take a look, A minus B, union B, and so on. Lots of more additional operation can be determined and represented. How about this one? How to make this shape? This one is looking complicated. It's not revolving, okay? It's not sweeping. It's not extrusion. But take a look. This is extrusion. Circle shape and extrude. How about this one? Primitive. How about this one? Also primitive. A intersection B will return this one. Union, union, and this one minus another one. At the end, the shape. Take a look, the operation representation. Where we put A, B, C, D, E operation, sorry, A, B, C, D, E name here, and then operations can be represented like this. At the end, this is the final operation, okay, for making this object. So this is Boolean operation. So making 3D is something similar to this process or the mechanism that I showed you before. This is SketchUp interface. Take a look. If you create this kind of object, today we're going to do something similar to this one, okay, today in the lab exercise hours. There are components, okay, subtract. You can easily subtract by using some other components like this way. So at the end, you can get this kind of subgeometric shape, okay. This is the easiest way to create that kind of shape. Okay, the last topic today is rendering, okay. This is the last topic for today's lecture. One of 3D visualizations, V-Ray rendering. Okay, we actually have reviewed this rendering before, but today we're going to take a little bit more about V-Ray rendering. So we are saying this is V-Ray rendering, but how about this one? Which one is rendering? Left one, right one, or both? Both of them are rendering, okay? What is the term, the meaning of rendering? Rendering simply means something drawing, okay? So this is rendering, but not photorealistic, okay? This is photorealistic rendering. Why this is photorealistic rendering? Why it's photorealistic? Simply, it follows V-Ray's ray tracing mechanism as well as global illumination mechanism, okay? So let's take a look a little bit more about rendering. It's all about lights. Take a look at the series of representations. Okay, even if the visualization is not that good, but anyway, this one, the sequence, the procedural visualization shows you what's the difference. Okay, is this rendering? Of course, this is rendering. This is line stroke rendering, line drawing rendering, okay? How about this one? This is color shading, color fill. This is shadow casting, which means there is light source, okay? There is a light. How about this one? Texture mapped. And this one has ray trace, okay? Ray trace. What is the meaning of ray trace? Ray tracing. What is the meaning of ray? Sun ray, lighting ray. Okay, if there is sun, there's supposed to be some type of ray, okay? This is ray, okay? What is the meaning of trace? Trace means track, following, tracking, okay? So ray tracing means 광선 추적, okay? If there is object, some rays going to be reflected, okay? Reflection. Some rays going to be kind of observed, okay, to the surface, diffuse. If this is transparent, some refraction. And this is, you know, what this meaning of reflection and refraction, okay? And surface, diffuse, okay? Very complicated physical interaction happened while there is lighting and the target object. Refraction, reflection, diffuse, lots of mechanism, okay? Very complicated. Anyway, anyhow, they going to be handled by computers. That's the meaning of ray tracing, okay? Computational handling about lighting source and their interaction between objects. So there is a lighting source, target objects, camera, main components, and take a look. The difference between left one and right one. Which one is looking realistic? This is also looking realistic, but not that much. Take a look. This part is supposed to be something green color because this face, this wall has green color. Take a look, the reflection. Red, white, green, okay? But this one doesn't affected by green color because this is not global illuminated. This one is global illumination based rendering, ray tracing based rendering. How about this one? If this is a sphere, ball, crystal ball, this is caustics, okay? This is real interaction between lighting source and this object, okay? So that's why this one is global illuminated based upon ray tracing, so-called photorealistic. This one is looking realistic, but actually not real. This is totally computer generated, okay? So that's the difference between these two different rendering. This is rendering, but this is ray trace based global illumination rendering. Simply say, your V-ray. If you use V-ray, you can make this kind of ray trace space global illumination. So rendering overview, not that many things you need to take care of, okay? Looking complicated, but you have to remember the most important thing. The first one, diffuse. What is diffuse? Diffuse is the color, the texture, the shape, exactly what you see for each object, okay? So what if you change diffuse color? The object color going to be changed, okay? What if you click this texture map button and load texture map using your picture? The surface of the object going to be changed. Color texture map, also transparency, okay? Default is black. Black means it's not transparent. It's totally opaque. But if you change color to white, this one going to be transparent, okay? BRDF, take a look. Very complicated looking equation. This is the mechanism of ray and object interaction in this kind of real world as well as computational world. Next one is reflection, okay? When you create reflection layer, this is V-ray interface, okay? Under reflection, there is reflection amount, reflection rate. White means transparent, black means opaque. In other words, white color means 100% reflection, 100% reflective. Black means 0% reflective. So you have to control. Next thing you need to remember is glossiness option. Take a look. Number 1 glossiness is looking like this, and 0.5 glossiness is here, okay? So now you see the difference between glossiness, numbers, rate. So you have to control those things. How about refraction? In refraction, you have to take care of IOR, okay? IOR means index of refraction. Take a look, glass 1.5. How about diamond? 2.4. So take a look. 2.4 is here, diamond, and 1.5, that's glass. So when you see some cubicle or object looking like this one, you can figure out this is glass because it's IOR is looking like this. But if you have diamond, it's supposed to be visualized like this, okay? That's the difference between IOR. Even more thing is here, emissive, self-illumination. Something about illumination, not lighting. We're gonna deal with some V-ray lighting and series of options here today, but not this kind of thing right now. Anyway, take a look, 0 emissive and 10 times brighter emissive. Emissive means self-illumination. So those series of representative interfaces are the subject you have to take care of when we are dealing with V-ray in SketchUp today, but actually V-ray also in Rhino, also in 3D Max. So next year we're going to learn some 3D Max and mental ray, something different type of renderer. Also there are some different type of renderers such as Podium or Brazil and so on. But anyway, I told you before, behind the technologies, principles, they are all same, okay? V-ray invented by alien, mental ray invented by human, that's not true, okay? All from computer scientists who knows physical phenomena in real world, and they all defined them in computational manner. In other words, in mathematics, which means behind the technologies are all same. So that is why we need to take care of some keywords and the mechanism, okay? Not the interface. So one of the exercise today is here, converting this visualization into this kind of thing, but even much better one from the original, okay? Okay, let's have a 10-minute break and then move to the lab exercise.